Hello everyone, and welcome to the 3.1 lecture video where we're talking about applications of quadratic functions. And here it would be worthwhile to think back into your mind, what is a quadratic function? And of course, quadratics, they're types of functions. And so if we're just thinking about how to classify these kinds of things, you have functions and then there's a bunch of different kinds of functions. One of them would be a type of function that's called a polynomial. And then of course there's a bunch of different kinds of polynomials. And one particular polynomial is the one that's called quadratic. And the idea for a quadratic is that it has this x squared term is the highest power of x that you have there. And that's what would make a function to be a quadratic function. And quadratic functions, they can take many forms, but there are two main forms that we're interested in. There's one that's called standard form. And this is the one that would be familiar because of the quadratic formula, which requires a quadratic to be in the standard form before you can put the coefficients into the quadratic formula. And if that sounds mysterious to you, then we will think about the quadratic formula here in a second. But the standard form is the one that goes like this: ax squared plus bx and plus c. And then these coefficients like a, b, and c, these are the ones that we take and plug into the quadratic formula. And then there's another form that's highly useful for graphing, because the graph of a parabola, it has some features that are notable. It has a feature that's called the vertex, and that's the point from which we get these branches over here. This one is called the vertex. And the vertex form of a quadratic function makes it apparent where the vertex is. It's not really possible to tell that from the standard form. The standard form only gives us a convenient form to be able to find out where the zeros are. And so this vertex form, it looks a little bit different than the standard form. It actually resembles the parent function, which the parent function of a quadratic, do you know how it would look? The parent function for a quadratic, what should it be? The best bet, and of course it's the right one, it would just go f of x equals x squared. This would be the parent function. And then what you see about the vertex form for this one is that it is simply the parent function there that has some transformations. In particular, it's shifted to the right by h because of this thing over here. And then because of the plus k, it is shifted up by k. And so of course the parent function, it has its vertex just at the origin at 0, 0. And so we would go basically to the right by h and then up by k. The way that I've drawn this one, we know that this k value is negative because it's in the fourth quadrant over here. And so we would be able to graph, at least to place the vertex based on the vertex form. If we want to graph it very well, then we would like to find also where these 2 points are, these x-intercepts. These are very important points for any kind of a function. So we have over here some x-intercepts. A quadratic will always have a y-intercept as well. Exactly one of them, of course. As far as the x-intercepts go, it's possible, if you can remember, to have 2 x-intercepts, as in the case of this graph, or else we could have only 1 x-intercept if the vertex is just sitting on the x-axis. Or else we could have a situation as well where a parabola has no x-intercepts. For example, a parabola that looks like this one. It will never cross the x-axis. And so there are these 3 cases to think about. Now before we get into actually doing some applications for a quadratic and working on some of these problems, I want to at least remind you of a couple of the important things about quadratics, especially I'm thinking about the quadratic formula. This is a big one. Quadratic formula. Hopefully you can recall this one from memory. Can you? Why don't you go for it? What is the quadratic formula? Do you know why we use it? Of course, this one, it's used for solving some equations, quadratic equations that go in the kind of standard form like ax squared plus bx plus c equals 0. So this can be equivalent, by the way, if you have the standard form of a quadratic equation. This is the same thing as basically just setting that quadratic equation, which is here, as just setting it equal to 0, and this is going to find the 0. So basically this finds the x-intercepts, which also are called zeros, of course. This would find the x-intercepts of the graph of this quadratic equation. And then the quadratic formula, it gives the actual x-intercepts, it gives the x values here. It goes negative b plus or minus square root b squared minus 4ac over 2a. And so I know there are some kinds of mnemonics for remembering this one. What is there? I believe there's a song that's to the tune of Pop Goes the Weasel, is it correct? You'd have to, if you're not familiar with that one, you're going to have to check it out. I'm not going to sing it right now because that's not how I learned it, but I know that it's a very popular one, and so many people have learned it that way. I think that if you just write it down about 10 or 20 times, you'll probably remember it just by muscle memory. You'll be able to do this one as long as you can get it started. Negative b, and then the rest, it just flows. And so there's something to think about here, these x-intercepts. For one, look at this thing that's here, the one that's inside of the square root, this b squared minus 4ac. There's a name for this. It's called the discriminant. And the discriminant actually tells you how many solutions there are going to be. Or in other words, it tells you how many x-intercepts a particular quadratic function is going to have. Because think about it, you're taking the square root of something, and then you're adding and subtracting that from some other number. So if whatever's inside of here is negative, for example, you take the discriminant and you say this is negative, that means that there are going to be no x-intercepts, because we cannot take the square root of a negative number. So if this thing computes as something negative, you're going to take square root of a negative number. It's not allowed, so there's no x-intercepts. What about if this discriminant is equal to 0? Then what you're going to have is you're taking the square root of 0, which is 0, and you're going to add and subtract that from some number. Well, if you add 0 or you subtract 0, it doesn't matter. You don't change the number. And so you only would get one solution here. It would be the one that goes negative b over 2a. So there would be, in this case, one x-intercept. And we can say in particular which x-intercept that there is. It's the one that goes negative b over 2a and 0. That one will be there. And then we have also the last case of what's possible. If this discriminant inside of here is positive, then when you take square root, you'll actually get a number, and then you're going to add and subtract a number from something there. So you would end up with two distinct solutions, which means there are two x-intercepts. Now I want to remember as well something about a quadratic, which is that whenever you graph the thing, it's symmetrical. We've been talking a lot about symmetry. We have x-axis symmetry, y-axis symmetry, all of these kinds of things. Well, a parabola, whenever we graph it, it is symmetrical around something that's got kind of a obvious name. It's called the axis of symmetry. And the axis of symmetry is a vertical line always that goes through the vertex there. And we know the equation of the axis of symmetry, which you can remember that a vertical line, it should go x equals something, and in this case it goes x equals negative b over 2a. And there's a lot of ways that we could find it, but one of the ways in particular is that we know that the vertex, it always will be halfway in between the two x-intercepts. And so if you took the two different x-intercepts that are given here in the quadratic formula, and you just find the midpoint between those, you find which number's halfway in between, it will be this number. Which it makes sense because this is the number about which you're kind of adding something and subtracting something. If you just don't add or subtract them, you'll find the number in the middle, and it's this one. So that will be the axis of symmetry. And here we're just thinking about all of the kinds of useful facts about quadratics that can help us solve some of these applications. And I think that here we are finding a good stopping point. We'll pick up talking about some of the actual applications. We'll try some of these problems, and we'll be able to talk about a little bit more details. But hopefully this stuff is a review for you. If it's not, then it's definitely imperative that you go back, look at some of the stuff about quadratics, memorize again if you have not ever actually done it, or memorize for the first time in that case, the quadratic formula. It must be one of the most famous formulas that people know, and I think if you memorize it, you should know it forever. But that will be it for this video, and I'll see you guys in the next one.